All right, we got an interesting problem here. It's interesting in a couple of ways. It's found on page 223 in your textbook. This is example 4, quadratic functions in the real world, which is in chapter section 4-1, graphing quadratic functions. And what some of the things that make this interesting, one, it's a word problem, which everybody adores. But second, it actually is bringing in some skills that we're going to study actually later on, that we're going to be introduced to later on. So it seems to be, it's in an odd place here in our textbook, but I'm going to go ahead and do it anyway because it will introduce a couple of things. Now, if you go back to the beginning of the chapter, that was on page 219. You see at the very top of the page some information about a golf tournament that this guy named Eddie organizes, where he donates the money to charity. And then in example 4 on 223, we see some information where he's trying to determine some price increases in his golf tournament. And this is a further continuation of that. So you probably want to take a look at what's on page 219 as well as what's on 223. Leading up to this might help make it make a little bit more sense. But Eddie's got a golf tournament, and right now he's got 120 players, and they're paying an entry fee of $40. And he's considering increasing his fee by $5, but he realizes that he figures that every time he raises the price by $5, he's probably going to lose 10 players. And so our task is to determine what the entry fee should be to maximize the value of the pool. In other words, where does he make, if he increases his fee by $5, how many increases can he have, and what would the entry fee need to be where he would actually make the most money before the number of players he loses starts to cut into his income. So we'd set this up like this. So we've got 40 players that are currently playing, and Eddie determines every time he increases the entry fee by $5, he is going to, well, this is the number of increases. X would be the number of increases that he has. And he's starting out with 120 players, but he also knows that he's going to lose 10 players every time he has a price increase. So X is equal to, that variable is equal to the number of price increases that Eddie is going to take a look at. Now, in order to develop our quadratic equation, we're going to use a technique called FOIL. F-O-I-L, where FOIL stands for first, O stands for outer, I stands for inner, and L, let me make a better L there. L stands for last. And this is how we're going to multiply these two binomials here using FOIL. So I multiply the first numbers, the 40 and the 120, and we get 4,800. 40 times 120 is 4,800. And now we're going to do the outer numbers, the 40 and the negative 10x. So that's negative 400x. And then we're going to do the inner numbers, 5x and 120, both positive. So that gives me plus 600x. And then the last, the 5x and the negative 10x, and that's going to equal negative 50x squared. Now I'm going to rewrite this in more of a general form. So I'm just going to switch this around to negative 50x squared plus, combine these like terms right here. So 600, positive 600x minus 400x is going to give me 200x plus 4,800. Now, I've got a common factor of 50 into negative 50, 200, and 4,800. All of those are divisible by 50, and technically I could do it by negative 50. But I don't want to because I want this to be a maximum value. And if I've got a negative coefficient to my quadratic term, I'm going to have a maximum value on my parabola. And if I were to factor out negative 50, then I'd end up with a minimum, and that's not what I want to see. So I'm going to factor out 50, and when we do, that's going to give me negative x squared plus, and 50 will go into 200 4 times, 4x, and 50 will go into 4,800 96 times plus 96. Okay. And so I can use this negative x squared plus 4x plus 96 as my quadratic formula. Now, we learned from the axis of symmetry and the x-coordinate of the vertex, I can find that maximum value. And first off, why do I know it's a maximum value? Because I got a negative coefficient on that lead term. That -1 tells me that that's going to be a maximum value. And if I use the little formula, negative b over 2a, well, I can find that x-coordinate, and that tells me x is the number of increases that Eddie could have. And so let's complete that. So if I plug in -4, in other words, minus +4 over 2 times -1, and then that's going to be -4 over 2 times -1 is -2. And so the x-coordinate at the vertex, or the value of x at the maximum value, is 2. And let's see, so that gives, he can do 2 increases, and so his entry fee after 2 increases, that's going to give him the maximum value. Well, let's see, 2 times 5 is 10 plus 40, and that's going to be $50 for the entry fee. And just for fun, if he loses $10 every time he increases, 10 players, I mean, if he loses 10 players every time he increases the fee by $5, well, let's see, he starts off with 120, and minus 10 times 2 would be minus 20. He'd have so y, the y-coordinate at that vertex is going to be 100, or 100 players, paying $50 each, and I think that would be $5,000. All right, we're going to go over to the calculator and put that in, and also learn a little bit of a skill of how to calculate or use our calculator to find the maximum value. Okay, if you remember, we developed an equation, a quadratic equation, negative x squared plus 4x plus 96, as being a quadratic equation that would help us determine the maximum value, or the maximum number of times that Eddie could increase his entry fee in $5 increments and get the highest amount of revenue from his golf tournament. So let's go in here and let's graph this. So let's see, we're going to clear, and we've got negative x squared plus 4x plus 96. Now, I think the first time I look at this, I'm probably not going to be able to see much of that graph, but then we'll make an adjustment and go from there. Let's see what happens. All right, so I can see part of the graph, but not all of it. So I'm going to go to Zoom, and I'm going to choose option 0. Let me scroll down so you can see it. It's Zoom Fit is what it is. So I got Zoom Fit, and I'm going to enter that, and that should let me see all of the graph. Okay, and it does. I can see here that my top end is a little bit higher. And you know what? I think I'm going to go on my window, and I'm going to change that even more. I'm going to change my Y maximum to, let's change it to 101. Because it's at 0.99 right now, and I can just barely see the top of the graph. All right, well, that gives me a little better view of it. Now, I'm going into Calc. I'm going to hit Second Trace, which is the Calc button. And I'm going to choose the maximum, because I see that I got a maximum value up at the vertex. I'm going to hit 4. And I'm going to be looking for what is the x-coordinate at this maximum value. And you can see down here on the left, it's saying left bound with a question mark. So I'm going to get it near that, what I think the vertex to be. That's pretty close right there. That might be almost right on it. I'm going to back it back one. Okay, we'll say left bound. Okay, enter. And then it says right bound, so I'm going to move it just past where I think the vertex is, and it says right bound, and I'm going to hit enter. And then it says, you want us to make a guess? And I say, sure, why not? Okay, and so it shows the maximum value when x is at 2, and it's got what, 1, 2, 3, 4, 5, 6, 7 decimals. When x is 2, y, that'd be the number of players, is 100. So we'd have two increases from that $40 fee, or $50, which is what we also found when we used the negative b over 2a formula to find the x coordinate of the vertex. So we're merging a lot of things that we're getting ready to do here in the next couple of chapter sections, which actually makes this kind of interesting.